All right, let's see what you did on this one here. Example 6, the instructions are always the same. Solve, no, just kidding. Prove, prove. So you know it's an identity to begin with. If you got stuck, I'll help you out. There's a line down the middle. Okay, don't let that be the thing that kind of stumps you in the beginning. You can always remodel it. Like if you need more room, you can always kind of remodel it. Remodeling is fine. Okay, you can make it slanted if you needed to. You know, it's really just there. Remember to keep you from cross-contaminating both sides. All right, but I'll keep it as a vertical line for now. So first of all, we need to decide on which side to start. And who wants to share? Did anyone get it all the way? You did? What side did you start on?
I started on the left side.
You start on the left side, okay? So if you start on the left side, boom, the right side becomes your target immediately.
Yeah, but I worked both sides as I went on.
Okay, that's not bad. That's one of the strategies that we're going to extract from this example. Because some of them, pretty easy to work down one side. This one you kind of run into a little snafu. What did you do on the left side to start with? Just curious.
I replaced cosine squared of. I put it cosine squared of cosine. I replaced cosine squared of phi or whatever it's called with cosine squared of x minus 1.
Okay, good. If you notice in the bottom you have 1 plus cosecant, and you know you can write cotangent in terms of cosecant, right? That's one of the things you know because you have memorized your identities. And if you don't know what it is exactly, just come off to the side and write it out in terms of whatever variable you want. And then you could say, cotangent squared of x is equal to cosecant squared what? Minus 1. So cosecant squared of x minus 1. I'm going to use x. It's a little bit easier than phi. And then you got 1 plus cosecant of x. Okay, sweet. Now, this divides out with that, and that divides out with that. The whole world explodes if you do that. Yeah, cosecant squared minus 1, remember, is a difference of two perfect squares, which means it factors into the product of two what conjugates? Conjugates. So that would be cosecant of x plus 1 and cosecant of x minus 1. And at the bottom, you got 1 plus cosecant of x. Then, does anything happen here? Yes. You don't have to show the commutative property here, but if you're going to divide out factors that are more than one term, you need to put grouping symbols around them. That divides out with that. And you're left with cosecant of x minus 1. And at some point, you keep your eye on the target on the right-hand side, and you're like, oh, boy. How we doing? Well, we were kind of in a zone right there, right? No, don't mess with me. Tunnel vision, man. Phew, got it done. And we simplified it down to something pretty handsome. Would you admit? I mean, you take that to prom, right? Cosecant minus 1. Maybe. Rain wouldn't. I bring that up because, again, prom tickets are on sale at lunch. Don't forget. Don't forget. At this point, we look at the right side and we realize that there's no cosecants on the right-hand side. And we have it down to something that's so simple, if I were to continue going on this side, we would be now having to build it back up to make it look like the right side, wouldn't we? So at this point, rather than try to build it up with some insight, this is the perfect time to jump over to the right side and see if you could chip away at that and make it look like cosecant minus 1. That's what I would recommend. So let's do that. Yeah. Wait, if you know what? Is what?
1 over cosecant. No, cosecant.
You would need to show that. Yeah, what you don't have to show is cotangent times tangent is 1. That I'm fine with because those are reciprocals. But yeah, that's what I would do. If you notice the left side, I have 2 terms. The right side, I really only have 1 term with 2 factors. So in order to get 2 terms to head in that right direction, I would distribute. So let's do that. We got cotangent. Remember, I'm using x, so feel free to change the variables. Minus cotangent of x, tangent of x. And I want to show that that's cosecant minus 1. So each term now I can focus on separately. If you just went from cotangent times secant to cosecant, I would take off a check because that's not immediately obvious. All right? But if you're not sure if the product of 2 trig functions or the quotient of 2 trig functions simplifies down to something, what can you do to see what it simplifies down to, if it does at all? Put it in terms of sine and cosine. That's kind of the common denominator among all trig functions. So cosine over sine times secant is 1 over cosine. Minus. Now, cotangent times tangent, if you want to call that 1, I'm fine with that. Because that's straight from the reciprocal identity, straight from the identity. We don't have an identity that says cotangent times secant is equal to cosecant, okay? But again, in this case, if you want to just say cotangent is 1 over tangent times tangent, or you could put them in terms of sine and cosine, cosine over sine times sine over cosine, whatever you want. Now, those divide out, and you're left with 1 over sine, which is in fact cosecant. And then tangent times 1 over tangent is 1. And now they look identical on both sides. And so now you're done. All right? So that's probably the most efficient way to do it, believe it or not. Now, in the spirit of trying to stay on one side, if you wanted to continue working on the left side after you jumped over to the right, all you would have to do is keep copying these steps in reverse order down here on the left-hand side. So like this would here be the next line. So you copy that, you would paste that over here. It would look like that. And then the next line would go below that, so on and so forth. So that's kind of cheating. It's like working a maze from the inside out rather than the outside in, which is a lot easier. You don't hit the dead ends. But it works. Because remember, as long as the lines on both sides on the bottom are the same, you've created this logical loop of equivalent statements. And you could jump in on any line and go in any direction, and everything's the same. They're all equivalent to each other. Okay? So the kernels to extract from this are change the variables if you don't like the given ones. That's fine. Just don't forget the variables or you'll lose a check. And then work on both sides, and as I said with Diamond Rio, meet in the middle. Okay? No shame in doing that. No shame in doing it. I'd rather you get it right than be stubborn and stay on the one side. Did anybody do that a different way? Okay, that's probably the easiest way to do that. You could have done this, though. 1 plus cosecant, that's a prime time to multiply by the reciprocal, or the conjugate. And that would be another way to do it. And then 1 minus cosecant times 1 plus cosecant is 1 minus cosecant squared. And then you can write that in terms of cotangent squared, and they would divide out. So it's a matter of factoring versus multiplying. Either one. It's going to work out. All right, any other comments or questions on example 6? All decorating meeting today, when? Juniors. Mrs. Ortiz could use your help too. Seniors. During 7th period or right after school. Mrs. Lincoln has one today after school from 4 to 5. If you missed the one-act play last night, you can catch it again on Saturday or Friday. Both at 7, right? No matinee performance. Yeah. Okay, sweet. Example 7. Prove the following identity. Okay. Let's do this one together. Draw a line down the middle. Down the middle, not with an eraser. There we go. So now, remember, multiplying by the conjugate is something to consider when you have a trig function plus or minus 1 or 1 plus or minus a trig function. It would appear that we have 4 opportunities then to multiply by a conjugate, right? Both sides look almost the same. There are 2 terms in numerators and denominators. So let's explore that. Let's start on this side. If I were to multiply by the conjugate of either the numerator or the denominator, I would have to know which one I'd want to use. And that would require some insight working down the line. So rather than do that, let's just try it out. You want to multiply by the conjugate of the numerator or denominator? Top or bottom? T or B? One syllable. T or B?
Top.
T. I heard top. Top. T or B? And top, yells Rain.
Yes.
T or B? 2 choices. Top, yells Rain. For that, I'm going to go by the conjugate of the bottom. Yeah, okay. Rain. So if the bottom is 1 minus cosine, I'm going to multiply by 1 plus cosine, the conjugate of the bottom. And again, I don't know if this is going to be the direction that ultimately gets me to succeed, but I'm trying it out. So in the bottom there, I get 1 minus cosine squared. In the top, if you expand it out, it's a binomial squared, so you get square multiplied over square. 1 plus 2 cosine of x, they double instead of cancel, and then plus cosine squared. And now, those divide out? Yes? No. Hopefully now you know you get the humor in that, right? Those are terms, not factors. We can only divide out factors. But 1 minus cosine squared is sine squared. And in the top we got, we just got that. Bless you. So if you look at the right side as your target, you're like, yeah, we're making headway, aren't we? Are we heading in the right direction? I don't think so. It doesn't look right. Here's one thing that we could do. Because we multiply by the conjugate at the bottom, we have a single term in the bottom. And one of your strategies that sometimes works is splitting up terms. You can't split up denominators, but you can split up numerators. So you can call that 1 over sine squared plus 2 cosine of x over sine squared plus cosine squared of x over sine squared. It's the opposite of getting a common denominator. And now if you simplify that, 1 over sine squared is cosecant squared. Now look at this little clever association. In that middle term, you got cosine over sine squared. If you associate one of the sines with the cosine, you get cosine over sine, which is cotangent. And then the 1 over sine that's left is the reciprocal of sine, which is cosecant. I'm okay with you going straight from here to here. I can get that association. And then cosecant squared over sine squared is cotangent squared. So notice here I have to remodel. That's fine. Now you compare that to the right side, and you're like, I still am not there. I take one of the cosines and one of the sines. What's cosine over sine? Cotangent. And what's left? 1 over sine. Yeah. Mm-hmm. All right, but doing that doesn't, now I have 3 terms, and I don't even have any secants. So you could jump to the other side and try and match it with that, or sometimes you just realize, you know what, maybe that's not the best thing to do. So even though there are opportunities to multiply by the conjugate over the conjugate, I don't think that's what I want to do in this case. So here's the better insight. We try that, and then we go back to the drawing board, as they say. The thing that you want to notice here is that secant and cosine can be written in terms of each other. They're reciprocals of each other. So maybe you start on the right-hand side because you don't like secant as much as cosine. I get it. Let's write secant being in terms of cosine. Secant is 1 over cosine, and then you have plus 1. And then you get 1 over cosine minus 1. So that's how you do it. You can't just bring that secant to the top and call it cosine because those are terms, not factors. But once you do that, then you celebrate, hooray, hooray, because you created a complex fraction. And when you create a complex fraction, the next step is a no-brainer. It is to eradicate the complex fraction. And here we can't do state change flip because we don't have a single term in the bottom. We have 2 terms. So what we're going to do is lick them over lick them. Remember that? Lick them over lick them, LCM over the LCM. We only have one miniature denominator. His name is cosine. So we'll multiply by cosine over cosine. And now we distribute. We did a lot of this earlier in the year. So that when we get to this now, it's just like, boom, easy. Lightning McQueen. Go left to go right. So you distribute. Cosine times 1 over cosine is 1. Plus 1 times cosine is cosine. All over, cosine times 1 over cosine is 1. Minus 1 times cosine is cosine. And if you compare that to the left-hand side, you're like, yes. But for the color difference and all that jazz, it's exactly the same. So there you go. You're done. I heart pets. National Pet Day. So that's the way. That's the insight to this problem. Realizing that they look so similar, secant and cosine can be written in terms of each other. Now, you could also do it on the left-hand side, just calling cosines 1 over secant, and then multiply by secant over secant. All right? There you go. Comments or questions on that one? Was this a waste of time? No. No. Some people do math just for fun, like crosswords and Sudoku. Karl Marx did calculus in his spare time just for thrills. Did you know that? It's because they didn't have social media back then. Wasn't he a communist? Is that what you said? Yeah, he did. Yeah, it was. Yeah. Yeah, Karl Marx. Yeah. The Communist Manifesto for his day job, and then at night, integral calculus. Oh, it's fun. Okay. Yeah, no kidding, right? The point is that it's recreational, if nothing else. Recreational. Yeah. Fun. Fun. Kind of like petting a pet. Did we establish if anybody had an exotic pet? Someone said dog, and I'm like, whoa. Is it like a rare dog? You have a Pikachu. Oh, a Pikachu is a rare pet. What's a kinkajou? Is that a dog? No, it's like a kinkajou. Is it a lizard? Let me guess. Let's help me. Is it a lizard? No. Anyone else want to guess? A bird. No. Hang on. Is it like a rodent, like a rat? It's a monkey. A monkey. It's like a chimpanzee that rips your face off? Okay. Some people have chimpanzees as pets, and they rip their faces off. Yeah, they're like 8 times stronger than humans. So be careful. They look like they're don't got biceps, but man, they'll rip your face off. So you have a kinkajou, and it's a monkey. May I ask how you got a monkey? Oh, it's like a ringtail lemur, but different. Does he kind of hang out in the house, or you have him in a cage?
She hangs around.
She hangs out. Is she trained? Like, does she make dinner for you and all that stuff?
No.
Get your paper in the morning, brew your coffee?
She just destroys my shoulders. She's really sharp.
Oh, okay, okay. A kinkajou monkey. Interesting. Does she speak? No? She'll scream at you. Wow. So, just curiously, where did you get it? Is it legal? Is it illegal to have a monkey? Are we outing you on the World Wide Web right now? Is it illegal? It is completely illegal. Okay. So you got her on the dark web?
Yes.
Can you just walk into like Polly's Pet Shop and buy a kinkajou?
They had one for a while.
They did.
Yeah, there's a breeder in Texas.
Okay, sweet. That is sweet. I've never met anyone who's actually owned a monkey. That's pretty cool.
Oh my gosh, I'm so happy.
Yeah, a kinkajou. You should bring it to school one day.
You should. I have one.
You have? Does it fit in your backpack like vape pens? You just take it out in the middle of class and play with it and put it away when no one's looking? Okay. All right, kinkajou. Kinkajou. At the end of the year, we might have to have a bring your kinkajou pet to school day. That is awesome. I've always wanted a monkey. I always wanted a chimp because I had bedtime for Bonzo growing up and some Disney films. But then when they ripped that lady's face off, it's like, no, chimps are out of the question. But a kinkajou is pretty, they will not rip your face off. All right, cool. Well, happy National Pet Day. Sweet. Do you let it outside to go to the bathroom, or does it know how to use the toilet?
No, like it has a cage inside the house, but most of the time we just let it out.
But it knows to go in there to do its thing? It's trained that way? It's potty trained?
No, we.
That's awesome. That's awesome.
Kind of like
A cat with a long tail. Yeah, yeah. And what's her name? What's her name? Bella? Bella. Bella the kinkajou monkey. Sweet. All right. That's cool. That kind of made my day. Happy National Pet Day. Do you take her for a walk on a leash? Yeah. Because that'd be like cuteness overload, right? Walking a monkey. And you never see her again. Yeah. You got to be protective. Okay. Cool. All right. Let's go ahead and jump in example 8 together. Try and refocus. Monkeys. I know. We draw the line down the middle. We got to prove that it's true. It is true. Pick a side, any side. It's already in terms of sine and cosine. The right side. Okay. So if you're starting on the right side, the left side's your target. So notice then you want to end up with 3 factors of cosine. We already have 1 factor of cosine. So what I need to do is pretty much show that what's left on the right gives me 2 more factors of cosine. Oh, and here's another thing. I want to end up with a factor of sine squared on the right-hand side. So what should I do first on the left? On the right-hand side, sorry. Yes, just like the quiz yesterday, or was it 2 days ago? I forget. I'm thinking about monkeys. Sine squared of x is a common factor. Let's factor it out, and that gives me the factor on the left that I want. And that leaves me a 1 minus sine squared times the cosine of x that's there. So now, or the cosine of x, sorry. So now I have my sine squared in place, and what I need to show then is that this is equal to another cosine squared. Is it? It is cosine squared, a la Papa Pid. So you want to show that because it's a replacement, and if you want to put it in parentheses, that's fine to show the replacement, but it's not needed because we're going from 2 terms to 1. But I do want to see that step. And then cosine squared times cosine is cosine cubed of x. And then you can call sine squared 1 over cosecant squared, right? Why? I don't know. That's for the person that's not really paying attention, right? Yeah, it's already good as sine squared, so don't do that. It was legal, but it was, not necessary. So now that right side looks like the left side. Yay! Yay! Bella. Yeah. How do you spell Kikachu? K-I-N-K. J-O-U. Oh, a kinkajou. Sweet. Okay, so people looking at home can Google that, kinkajou. Because it sounded like you were saying kinky Jew. Yeah. And that's... Right? Right. Oh, wow. I never met one of them. That is a strange pet. That is a strange pet. All right. Did anyone start on the left side or think about the left side? No? Okay. Here's what I'll go ahead and work it. If you were starting on the left, which is just as is fine because you can take what's there and create what you need. So I need to keep one of those cosines out because that's the factor that I have over here. So the other one I'm just going to write as cosine squared times the sine squared that's there. Now you can say, all right, with this cosine squared that's left, I need to get rid of it and turn it in terms of sine because that's what the right side has. So now, oops, I forgot my x. What is cosine squared in terms of sine squared? It's 1 minus sine squared. And so here the parentheses are really important because now I'm replacing a single term with 2. And now it's just a matter of distributing sine of x minus sine cubed of x all times the cosine. And that's what the right side is. Oops. Sine squared. I'm distributing a sine squared. Sorry. This would be sine to the 4th. I missed the squared, so I messed it up. There you go. And so again, it's just a matter of whether you recognize something that's factorable or changing it and expanding it. That's kind of what Gilstrap did yesterday with the the secant squared. She changed it first and then distributed, whereas when I worked the key, I factored it and then changed it. So it's just how you see the problem. Everybody's a little bit different, and that's what makes it kind of nice. Grading these tests is always, it takes a little bit longer. I don't get them back to you the next day necessarily because I have to look at everybody's problem with fresh eyes and follow and track your process. All right, kinkajou. Let's go to example 9. This will be the last one we get to for the day, and then we'll finish up tomorrow with 10 and 11. All right, so example 9, it says to prove the following identity. I'm going to give you a minute to kind of figure it out on your own, and then we'll talk about it. Take volunteer. We got a dense nucleus on the left, and then we have the Big Bang explosion on the right. Yeah? Or it's like we have a tube of toothpaste on the left and it's squirted out on the right. So I don't know which side you're going to be inclined to start with, but we'll see. Go. 1 minute. I'll give you a minute. Think about it. Start. Do something. I'll be thinking about monkeys over here. I've always wanted a monkey.
Giving them a bath is like the worst thing in the world.
Oh, really? Worse than a cat?
Oh, yeah.
Yeah? Not really liking it? And does it pick its own fur and throw it at you like other monkeys? No? Okay. Some of those monkeys fling dung, right? Nope. No? Okay. Right. Another reason maybe not to have chimps. Well, some of them might be smarter than you at math. That would be embarrassing.
Yeah.
Your chimp knows Papa Pig and you don't. That's Does your monkey like hamburgers or pizza? Do you feed it like human food?
No, mostly fruit.
Mostly fruit. So a very special diet. Someone in the family has to eat fruit.
Every one of us.
Oh, really? Okay. It takes discipline to be that healthy. Some families eat little quiches. Right, Huey? Like, yeah, they're just...
Are you
Oh, they're packed with all kinds of good stuff. Good for runners. Yeah. Like cornflakes. The Tarahumara, have you heard of them? The Indian tribe, northern Mexico. They run with used tires on their feet, and they can run for like 52 days at a time. And they just carry like little corn cakes in their like belt stash. That's all they eat. Yeah, pretty good. All right, this is all just background talk while y'all are figuring this out. All right, which side should we start on? Anybody? Started on the right side. Definitely appears to have more information. Okay, sweet. So you would say that I got a cosine factor. I need to pick up 4 more to get a cosine to the 5th. So really our task is to show that this is equal to cosine to the 4th of x. That's our task, to show that. Okay? So I'm not going to really mess with that cosine out there. I'm not going to distribute. Did anyone distribute the cosine? That's obvious math, but it takes you further away from where you want to go. So leave the cosine out there. So anybody have an idea of what to do with this whole thing right here? Not really, no, because it's 1 minus 2, so that doesn't work. It would have to be 1 minus sine squared to call it cosine squared. You could call this 1 minus cosine squared, but that's not going to quite work either. Starting on the right, doing something with this is kind of hard to see. But here's what might trigger some kind of reflex, mathematical reflex. If you write it in descending order, you have a squared term and a non-squared term and a constant. And by squared, I mean you have an even power and then half of that even power and a constant. It doesn't have to be a 2 or 1. As long as the larger one is twice the smaller exponent, it could be a factorable trinomial. So it could be a 10 and a 5 or a 100 and a 50 or an 8 and a 4 or in this case a 4 and a 2. This could factor into the product of 2 binomials. So here's how it might factor. What's the square root of sine to the 4th? Sine squared. You just take half of the exponent to take the square root of something. And then 1 only factors as a 1 and a 1. And now to get the middle thing to be a negative and this product to be a positive, they both have to be negative. So they're both actually equal to sine squared minus 1. So that was actually a perfect squared trinomial. But again, that might be hard to see. Factoring is a little bit more advanced than expanding. Now I can use Papa Pid and replace both of those. What is sine squared minus 1? Not cosine squared, believe it or not. So here's where you have to be careful. You don't want to lose a point at the end. When in doubt, come off to the side and write out the identity. Cosine squared plus sine squared is equal to 1. So sine squared minus 1, you would have to bring the 1 across here to make it minus 1, which means you need to clear the cosine out, so it would become negative cosine. Yeah. So in parentheses, that's negative cosine squared. And the next one is also negative cosine squared times the cosine. And now, what is a negative times a negative? It's a positive. Okay, so it does end up being positive, and then squared times 1, you can go straight to cosine to the 5th. But if you didn't have those as negatives, that's where you would lose a point. Okay, because that's kind of important. So when in doubt, go off to the side, write your identity out, and manipulate it there, and then bring it back into the problem. So that's one way to do it. But that did require noticing something that factored. And so as we do these, I'm trying to increase your awareness of other things that factor. So when you see them, that you know it's something that's a possibility. Now let's do it the other way. If you started with the dense nucleus, it almost ends up being a little bit easier. So I want to keep one of the cosines out. So I'll keep that cosine of x out. And then the other ones leave me as cosine to the 4th. Now I don't have an identity for cosine to the 4th that puts it in terms of sine. I can call it 1 over secant squared to the 4th, but that doesn't help. So what I'm going to do is call cosine to the 4th. I'm going to call it cosine squared squared. And notice I'm writing the square 2 different ways. But that's the same, right? Cosine squared squared. Or write it as cosine squared times cosine squared, side by side, if you want. Because now, in terms of cosine squared, I can write it in terms of sine by Papa Pid. So in parentheses or side by side as 2 separate factors, Cosine squared is 1 minus sine squared. Okay, so whether you have now 1 minus sine squared times 1 minus sine squared and you FOIL it, or you have 1 minus sine squared quantity squared, you can now expand it out. Don't forget to bring your cosine down on that line. On this line here. You need it here. Yeah. Okay, so how do we expand? Well, if you have it side by side, you're probably going to FOIL. But if you have it written like this, you square, multiply, double square. Square, multiply, double square. So in parentheses, we square the first and we get 1. We multiply and double, we get minus 2 sine squared. And when we square the last, we get positive sine to the fourth. Times the cosine that's sitting out there, and that ends up being the right-hand side. And you're also done. Monkey business. Okay, so either way works. Now, as you're working these proofs, it's easy to kind of get caught up, but make sure when you finish, go back through and make sure, like when you're working on something like this, make sure you're bringing down the cosine every time. Because if you miss the cosine on one line, like for instance, if you leave this cosine out because you're focusing on the other thing, guess what? When I'm grading your test, guess what? You're going to lose a check there. These are going to be worth 2 checks, essentially one for making a good first move and then one for finishing it off. And so if you know how to do it and you just missed a careless check because you didn't bring something down, that's going to be kind of painful. So make sure that you're diligent and bring everything down from one line to the next. All right? And now we're done. Those are the 2 easiest ways to do it. Did anyone do it by putting in terms of tangent? It's good. Probably didn't want to do that. It's not a good way to do it. I liked it, the snaky line. Your lines don't have to be straight, right? You don't have to wear starched shirts all the time. You can just make it interesting in the beginning. Draw kind of like a snaky line and then try to follow it. Have fun with these, right? Have fun with them. They are fun. Just ask Karl Marx. Okay? All right. I think we're going to stop there for the day. We've got a few minutes left, 4 minutes left. We have 2 to do tomorrow. Worksheet to be due on Friday. And we'll have a quiz on Friday. Okay? Don't forget your prom tickets at lunch.